All right, good morning, folks. My name's Ivan Tolson. I work for Green Button. We are a cloud platform provider. We provide solutions for high-performance computing in the cloud, so compute-intensive operations. And one of the things that working on the cloud has kind of illustrated to me is how, as a programming community, we're moving more and more towards that kind of distributed model of computing. It's not just in the cloud. There are more and more devices out there. There are more and more systems that we interact with. And these systems are not always under our control. We cannot always predict what they're going to be doing. And this results in having to deal a lot more with asynchronous data. Who here remembers programming for DOS? DOS! Oh, this is fantastic. What about Windows 3 or Windows 2? Windows 2 or Windows 3? Yeah, Windows 3. So in the DOS and Windows environments, you were totally in control. You would run your, in DOS you have your own program loop. You would do whatever you need to do. You would poll the keyboard or whatever. You would sit there and wait. In Windows, you had the beloved message loop. While peak message, get message, translate accelerator, dispatch message, until post quit message. It was beautiful. You were totally in control. Sadly, those days are no longer around. We have got to deal with so many different things throwing data at us. And one of the things that has been happening to support that is a lot of development around the asynchronous program model. In the last session, those of you here for Ian's Node session, you saw Node's concept of evented I/O, the fact that everything happens on callbacks. You don't block on anything. You've got the crazy squid wiggling up and down. All the work is done by the bunnies, and the bunnies call back to the squid. If you weren't here for Ian's Node session, I have not taken any drugs. This is actually how he explained it. We've got in C#5 and the latest version of Visual Basic, we have the new async and await keywords, which allow us to efficiently do asynchronous operations like calling out to a web service, a REST API, for example, while keeping our user interface responsive, not necessarily consuming a separate thread, and not having to write these complicated callback structures. So we've simplified the programming model. One thing, however, that neither of those approaches really has addressed is the problem of asynchronous data as streams. So the async await kind of design handles really well this kind of ad hoc asynchrony, where you're making a call to an asynchronous resource, and then when that resource is available, you deal with the results. What if you're dealing with a continuous stream of data, a continuous, unpredictable stream of data? So dealing with synchronous data is really easy. You've got a variable x, you apply a function to it, you get a result. Life is good. It's like being in DOS. With this ad hoc one-off asynchrony, we've got a couple of things. We've got asynchronous operations where I've got an asynchronous function, takes an x, returns me a task. I can await that task, and my function will get woken up when that task completes with the data that task returns. If I've got async data here, my x2 is a task. It is something, it's a piece of data that I'm that is going to arrive at some point, I don't know when. I can still handle that by doing an await on that x2 and then applying my operation to that when it arrives. We also have great mechanisms for dealing with synchronous operations with operations on synchronous streams, and we call these link. So here I've got x's, I've got a sequence of data, and I'm able to transform or filter that data in a very readable, very compact way. And I can, as you're used to from link, I can compose those operations. So I can take a stream of data, I can filter it, map the results of that filtering, and then filter the results of the mapping of the filtering. And it all flows through pretty nicely. The problem is that if you've got asynchronous data, then the async await pattern does not compose well in the same way that link does. You can imagine some sort of rather ghastly attempt at doing this using link, where I say, well, I've got a sequence of data and I'll do a mapping and I'll use an asynchronous lambda, because everyone loves asynchronous lambdas, and that way I'll do an await on something, and that's kind of asynchronous, right? Well, yeah and no. If you're going to use that select operator, then it's going to be pulling data from the X's stream. And if X's is unpredictable, if there could be minutes or hours or days between elements, if you don't know when those things are going to happen, then you can't afford to block on that thing. What's more, this is just going to give you, if we have a look at this just gives me an IEnumerable of tasks, which means I've got two problems on top of the first one. Firstly, I've got to pull things off that sequence of tasks, and again, that's a blocking operation. And secondly, what I get back is a task. I suppose I could probably do a wait task.whenAll or whenAny or something like that, but it's getting a little bit unmanageable. It's not guaranteeing me order, things like that. So that's clearly not a solution. We could try to produce something like this, where we've got some producer method that's producing data in an asynchronous way. So every time I call it, it's going to give me a new task, and that task will complete when the next piece of data is available. So I can do a while true, I can await on that, and then I can do my filtering, I can do my mapping, I can do some filtering on the results, and then I can somehow, in some way I haven't quite figured out yet, pass that result of that each time, push the data that I've transformed and filtered onto whatever wants to consume it. You can see that is not quite as composable as the link style of design. We could try doing the same kind of things with events, but to cut a long story short, it still sucks. So what kind of design, I've tried these various things. What kind of design would I actually like for this stuff? Well, for those of you who know me, I would like it to look like Link, because Link is awesome. I just can't get enough of that stuff. I would like it to look like Link. And in order for that to work, I need, I guess, three things. I need some equivalent to IEnumerable, the synchronous stream abstraction. I need an equivalent to that for asynchronous streams, for unpredictable streams of data. I need a set of operators, a set of extension methods on that abstraction, on the asynchronous stream, to allow me to do these filtering, transformation, grouping, bucketing, whatever kind of operations. And I need some way of processing the result, processing the data as it emerges from one of these asynchronous streams. Well, the good news is that the .NET framework includes exactly the interface we need. There's an interface called iObservable. It's defined in .NET 4 in the base class library, and its purpose is to represent a stream of data that is not pulled from, that pushes to your application, that pushes to its consumer. The bad news is that nothing in .NET 4 implements iObservable, so it's not a terribly useful interface. There are no extension methods for iObservable, so although they have defined this thing, there's not actually a whole lot that we can do with it in the raw framework, unless we write some code. I don't know about you guys, I'm too lazy to actually write any code. That's where the reactive extensions come in. Reactive extensions address the two questions of where do I get an observable from and how do I process that observable. They are a library, an open source library that contains a number of factory methods for creating observables and a number of link style operators for working with observables. I'll come to the third question in just a moment. So let's have a look at how my dream might actually work out in practice. So let me imagine that I've got something that creates observables. In this case, I want to I want to deal with a set of things coming out of the file system. I'm going to be monitoring file system changes, and I want to represent those in my application somehow. This is a very simple example. In reality, you're probably using this for more sophisticated kinds of data, but this is something I can create changes in my file system quite readily, often by accident, in fact. So I've got a method that creates an observable of file system happenings. Now, I can apply operators to that. So I can say, I've got my sequence, my asynchronous sequence of things that are happening in my temp folder. I can filter those so that I only see file creations. I don't have to deal with all of the events. I'm going to filter them down to file creations. I can then map those file creation events into some other type that is more convenient for me to work with using a select operator. And finally, I can use another where operator to filter it down to only dealing with files that begin with the letters my. You can also imagine going a little bit further. You could, for example, ask to be able to group by some sort of criterion, maybe the initial letter, so that I'm getting a sequence of buckets or a sequence of sequences for with these things. All right, so given that I've got this observable object, how do I actually process this sequence of asynchronous data? Well, with IEnumerable, with link, we've got the for each keyword built into the C# and Visual Basic Language, which allows us to iterate over a sequence, and that will keep pulling and pulling and pulling from that sequence. That's not really going to work for us in the asynchronous case, because for each is just going to keep going round and round and round, blocking until it reaches the end of the sequence. So what we can actually do is we can look back at the way that events work, because we've had events since .NET 1.0. They work pretty well, apart from not being first class and sucking. But the whole idea of hooking up a callback to an event, so that whenever the event fires, we get called back with the event data. Well, actually, that seems to work reasonably well within certain well-defined limits. So what iObservable defines, if we go and have a look at it, is a subscribe method. And subscribe just takes an iObserver. Well, okay, down the rabbit hole. What is an iObserver? An iObserver is essentially it's three callbacks. Because we want to be able to receive values, because the sequence might finish at some point, and because we might get errors being emitted by the source of the data, we've actually got more than one callback. And this is something that makes observables much richer than events, in that they can say, I'm done, there is no more data, or, oh my goodness, someone trod on the Kinect. You've got that additional information. You've got that additional control over the sequence. And that allows you to, we'll see later on, that allows you to sort of build up a little bit more control over your handling of these sequences, how to fit these things together, how to deal with some of these situations. The downside of having the iObserver interface is that you end up writing lots of little tiny iObserver classes. Has anyone done Java, something like AWT or Swing programming? Yeah, so Java uses the observer pattern as well. Because Java doesn't have delegates, Java uses local classes or inner classes to simulate or to do the same kind of job. So you end up with all these little tiny button click handler classes or whatever, which are only there to provide this one method. And it's kind of the same with iObserver. Often you just want to say, whenever I get one of these events, whenever I get a file system event, I want to write it to the console. I want to write it to a log file. I don't want to create a writing stuff to the console observer. That's going to be quite tedious if I'd have to do a lot of it. So one of the first things that we get from the reactive extensions is a helper, an extension method, which is also called subscribe, but just takes a delegate, just takes a callback. So now I can have that very event-like syntax. I can say I'm going to have my temp folder events. I'm going to transform them into a useful form, and then I'm going to subscribe to them so that whenever the file system pushes one of these events at me, I'm going to do something with my view model, and that will be reflected in the user interface. So if I run that up, we get the traditional developer user interface, the blank screen, and I can rename files, I can edit files, and you can see that those changes are being picked up in much the same way as an event. But what I've been able to do that I couldn't have done with the pure event handler is to filter those or to transform those in a composable, readable way using those link style operators. What happens if we want to deal with more than one of these events? Well, I've just been using the last one there, but of course, if I want to actually produce some sort of file logging thing, I might want to add these to a collection. I'm in WPF here, so I've got a list box down there, which, as I do stuff, let's just rename that back to something sensible, and bam. What's the problem here? Well, WPF is quite sensitive as to what thread you're allowed to do stuff in. Because the way that my file system event provider is implemented, those events are firing on a background thread somewhere, I don't know where, somewhere deep inside the .NET framework or inside the operating system. I was able to modify that last changed property because WPF does some magic on scalar properties. But the WPF developers kind of lost the will to live when they got to collections, and they didn't do that helpful stuff there. So this is a bit worrying. Does this mean I have to start mucking around with dispatcher.invoke and all of that crazy stuff? Well, once again, reactive extensions to the rescue. What I can do with Rx is I can use the observe on operator and say, well, I don't care where these events, where this asynchronous stream of data is being pushed from. I don't care what thread you're on when you push it. I want to observe it on my WPF thread, on my UI thread. That is to say, I want the subscription code, the thing that happens when I subscribe, I want you to run that on the dispatcher thread, regardless of where all this crazy data is coming in from. So when I run that up and start frolicking in the file system, you can see that that thread issue has gone away, and I can edit this to my heart. Oh, Well, that's a bit funny too, because every time I save this file, I'm getting 2 file system events, which is it's mucking up my user interface. So what am I going to do about that? Well, again, if I was handling those events directly, I'd have to maintain some sort of state and kind of look for, well, have I got one event pretty quickly after another? And it's all not very nice. With the reactive extensions, I can timestamp each of those events as they happen, and then I can do a distinct until changed, but I don't want. So I want to look for. I want to look for things which are. Oh, sorry. I want to eliminate things that are the same, in the sense that they have a very similar. That they're dealing with the same file and they have a very similar timestamp, because that means they're probably spurious changes. So we're going to go to E goes to E dot value dot change type. Oops. Let me just check I'm doing the right thing here. What am I looking at? I want a I quality comparer. That's not going to be. Oh yeah, there we go. System. So E goes to E dot value plus E dot timestamp dot to string, let's say y mmdd hh sss ff. So if they happen within, say, 1/10 of a second, then, and now of course I got timestamped events, so I'm going to need to get rid of that. So I now go to E goes to E dot value to get rid of that timestamp again. I was only interested in it for the purposes of that comparison. And if I've got that key selector correct, then I'm hoping that editing this stuff I will no longer be getting these spurious changes. So I've been able to use my composable operators to do processing in a pipeline to perform transformations. I could have performed filtering. I've got this elimination of duplicates. There's all sorts of things that I can do within that pipeline, and I don't need to write complicated custom code to do it. How many people here went to Clint's Connect talk last night? Was that cool? Yeah, that was cool, but there was a lot of code in it, which I felt quite bitter about. I loved the face tracking demo. So for those of you who weren't there, on the Kinect, it's got the new Kinect SDK has got this face tracking feature, which can only be demonstrated by doing the dance. So you can detect the pitch of the head. Everyone join me. The pitch of the head. You can detect the yaw of the head, and you can detect the roll of the head. And Clint had some very simple logic for detecting when somebody was nodding using the pitch or shaking their head using the yaw in order to display user interface in response to that. And he was basically using logic along the lines of if it's above or below a certain pitch or whatever. With something like reactive extensions, you could imagine converting that stream of pitch, yaw, and roll data into an observable sequence, and then you could use operators, for example, windowing operators or buffering operators, to capture the trend over, say, the last half a second or something like that. And you could actually then analyze, is the head moving up and down, or is it moving more side to side? How can I compare these? So I think for something like that, again, that's an example of a device where you could simplify things. You could simplify your code by using these link-style operators. So where do observables come from? I've manufactured one, but I've kind of ducked to the issue of how did I manufacture it. So let's dive into this file system, what's happening in method, and see what's going on. Well, the dirty secret is it's all .NET 1.0 under the covers, pretty much. Who remembers the file system watcher? Oh yeah, who remembers all the bugs in the file system watcher? Fantastic, that's why demo has not crashed yet, I'm so glad. So all I'm doing is I'm setting up a file system watcher, and I'm using this Rx helper method, observable.fromEvent, to say, I want to take a traditional .NET 1 style event, and I want to turn that into a data stream, an asynchronous data stream. Now, unfortunately, this looks a bit more intimidating than it actually is. This is due to a bug in the current build of Rx. In theory, there's a simpler overload for observable.fromEvent, which you basically just pass it. This is how to subscribe to the event. This is how to unsubscribe from the event, and it will just turn it into an observable stream for you. Unfortunately, like I said, there's a little bug in there at the moment, so I have to use this little additional hack to adapt the action type to an event handler. Don't worry too much about that. The key thing to bear in mind is observable.fromEvent. It takes a subscribe callback, an unsubscribe callback, and it will turn that event into that .NET 1 event into a stream of data. So I can turn the changed event into an iObservable. I can turn the created event into an iObservable. I can turn the deleted event and the renamed event into iObservables. But what I actually want is a stream of all of those events. And to get that, I can use the Reactive extension's merge operator. Now, this is an operator that hasn't really got an equivalent in LINQ, in IEnumerable land, because merge is inherently about time. It is inherently about asynchrony. If you think about trying to merge two IEnumerable sequences, it's kind of, well, we get stuff from IEnumerable by polling it. Well, which one? I'm going to block whichever one I ask. Have you got a new thing? I'm going to block. I can't go and ask the other thing. Well, he hasn't got one yet. Have you? I can't really wait on those things efficiently. With asynchronous streams, they are firing data at me. They can absolutely overlap, and I can subscribe to all of those streams and say that, well, whenever any one of those pushes data at me, then I'm going to just push that data onwards to my subscriber. And the result of that will be to create a merged, a combined asynchronous stream of those things. Once I've done that, I just turn the watcher on and return that combined stream. There's a question. The question is, how does the type compatibility work? Because each of those events seems to be a different event type. I'm glad you asked me that. They're not. If we have a look over here, then you will see that of the first three, they are all file system event args. So they are all completely type compatible. The fourth one looks a bit more worrying because that is a renamed event args. Fortunately, if I look at that, that inherits from file system event args. And because iObservable is super beard powers contravariant, covariant? Actually, I think it might be covariant. I really can't remember. I just like saying super beard powers. That means that it is compatible in that context with file system event args. You are absolutely correct, though, that if those had not been compatible, I would have had to use a select to transform them into a consistent representation before I could merge them. So, thank you. Excellent question. All right. So is that all making sense to you? We've gone from the world of .NET 1 style events, which were not first-class citizens, We couldn't apply filtering or transformation or whatever to them. We've transformed one of those into an asynchronous stream of data that is pushing data into this subscribe method, and we're then able to use these link style operators on it to produce a new stream of asynchronous data, this transformed, filtered, deduplicated data, and then subscribe to that to actually get stuff done. All right. Just to give another example of data coming out of an observable from event, we can consider our mouse as a data source. And again, we just use that from event, and we can do a select on that, select get position, and subscribe to that. And this gives us a really very simple, there's no event handling going on other than that observable subscription. I can move that blue ball around, which is pretty triumphant. This is Windows 8. But let's start thinking about maybe creating a more exciting user experience. Could it be any more exciting? I'm telling you it can. Because we are dealing with time, which means we have operators that do stuff with time. Does anyone remember in Windows 95, you used to be able to get those, you used to be able to get cats that would chase your mouse across the screen? Yeah, I have cats like that. It's really annoying. They sit in front of the monitor and they paw at the mouse. But you can see in a very easy way, I've now got that ball chasing my mouse pointer. It's always a quarter of a second behind. What about combining streams so that I can have some more declarative way of having state in my user interface? Well, what happens if I'm only interested in, say, the mouse moves that happen while the mouse is down? Well, how can I represent that? Well, I want a sequence that's kind of, it's going to begin every time the mouse goes down. And for each mouse down, I want a sequence of mouse moves from that point onwards until there's a mouse up. And that sequence is going to represent exactly the mouse moves that happened while the mouse was down. So I'm doing a select, I'm selecting from the mouse down events. For each one of those, I'm selecting the subsequent mouse move events until I get a mouse up. And with my link style syntax, my link style operators, that take until gets me the mouse moves until the mouse goes up, and this chain of froms gets me mouse down, sequence of mouse moves, and then I'll again just do the get position to get me an iObservable of points, and then I can subscribe to that with my set position method. And so when I run that up, when I just move my mouse around, nothing happens. When I put the button down and start moving the mouse, it tracks, release the button, and once again, it's not tracking. Another way that we can create observables is, well, old school manually. We can write code. And this is not a very enticing option, but it's there if you need it. This is, again, this sort of the low level of the reactive extensions. So I can use this observable.create helper method, and that says, well, basically when someone subscribes, I will hand you that subscriber. So you specify observable.create with a callback. Whenever someone subscribes to that observable, they get that the observer gets fed to the callback, and the callback does whatever it wants. And how does it interact with the observer? Well, you can see there it interacts with the observer. The way it pushes values to the observer is simply by calling that onNext method. So basically, the observable, in observable.create, the callback just sits there going observer.onNext, onNext, 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 until you get to completed or error. This is pretty grim, as you can imagine. In particular, I really like those thread.sleeps. They make me feel really at home because I've been doing this for a very long time, back in the good old days. So in order to get away from that, we can use some of the more sort of atom-oriented methods that the Reactive extensions give us. So these are kind of building blocks. For example, observable.empty. Doesn't that name just resonate? That produces an observable sequence that completes without raising any data. It pushes nothing and then goes away. I could write that code. That would be awesome. I wish I had that job. Why is that interesting? Well, in and of itself, it's not interesting, but it's a building block. Because what I can do is I can use the delay operator. So now the delay operator is going to transform that sequence that does nothing and completes immediately into a sequence that does nothing after quarter of a second, and then completes. So I've effectively built a sequence that represents a quarter-second delay. I can also build a sequence that represents pushing a single value using this observable.return factory method. So now I can go, well, if I take an observable.return single point sequence and one of these delay sequences, another single point sequence, another delay sequence, and so on, and I concatenate all of those sequences, suddenly I've got something that gives me point, 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 with appropriate delays between them. But observable.create is certainly very low level. It's pushing things very directly into the observer. To get to a little bit of a higher level, we've also got observable.generate. This is more of a state machine or a for loop. In this case, I'm using it pretty much like a for loop. So I've got a loop variable, which is the integer, and it's pushing a series of points at its consumer. And I'm just saying, excuse me, it's going to start, my loop variable is going to start at 0. I'm going to keep going until it reaches 40. I'm going to add 1 to it each time. Each time I go around the loop, I'm going to check what's the current value of the loop variable, and I'm going to return an appropriate point. And observable.generate is going to capture the point that was returned and push that to a subscriber. So by going from observable.create to observable.generate, I'm no longer dealing with observers myself. I'm abstracting away from that onNext, onCompleted, onError treadmill, and I'm just pushing values using a standard, using standard C#, using just a standard return. And finally, I'm going to say, well, I'm going to do this every 250 milliseconds. So that's the, I want to transition every 250 milliseconds. For a more useful example of that, I might just have a much finer grained, every 10 milliseconds, I'm basically going to advance by 1 degree, and I'm going to yield a point on this circle. And in fact, this doing things by intervals is so common that there is a helper method. Doing things by time span is so common that there is a helper method to do it, this observable.interval factory method, where all that does is it yields a sequence of, you can see that's returning an observable of long. So basically it returns 0, 1, 2, 3 at the appropriate interval. And now, because of composable operators, I can transform that into a sequence of angles. So observable.interval, although it seems quite primitive in that all it's giving me is this is how many intervals have elapsed since you started, I can take that and I can transform it into whatever I need. So if I actually look at ways of using that. Let's get rid of the chunky one. I can take that get angle stream, dot from milliseconds to 10, and just edit up the app.xaml to use that. And you get a very exciting animation of the ball going round and round. And once again, it's observable. I can apply transformations to it. So, for example, I can do a matrix multiplication on it, for example, and it will now go in kind of crazy loops. Incidentally, if you're writing WPF or other XAML things, don't do animations that way. I'm really sorry. That's not there's animations built in. They are much more efficient. They're a much better way of doing things. But what that does show you is that composability, and it shows you how to actually create those sequences of data for yourself. We also have another a variety of other time-oriented operators, by the way. So if I didn't want to be seeing every single location on that circle, I might, for example, do a say a dot sample. And that sample method takes an input observable sequence, essentially starts a timer, and every 400 milliseconds it's going to go, right, what was the last version I saw from my source sequence? What's the last version? What's the last datum I saw? What was the last datum I saw? So I'm dipping into that sequence, filtering it. There are other operators such as throttle, which you can also use to reduce the frequency of incoming data. If you've got something that's very, very heavy, for example, if you've got something like a ray gun style error reporting service where you may be getting a lot of error data thrown at you during peak periods, you might use something like a throttle method to kind of slow that down. You need to be a little bit careful in that example with, for example, robustness with durability. But if your data is non-critical, there's something like throttle is a very simple way of just saying, look, just keep this to a level where I can actually cope with the frequency it's coming in at. All right. So this now raises the question of how do these operators work? And the first thing I tell you is that, as with LINQ, you do not need to know how they work. You can just use these operators. They just do work. Apart from that overload that's got a bug in it. That doesn't work. But basically, you use them, you don't need to be too worried about it. But I need to know how they work, because I'm nosy. So, how do they work? Well, let's dive in and let's try and write them. Let's try and write, for example, the where operator. And, well, we know that the where operator is going to take an iObservable and a predicate, and it's going to return a new iObservable of the same type. So I'm going to create a new class, a new observable class, to represent the result of the filtering. I need to return an iObservable, so I'm going to create a class that implements iObservable. And I'll just initialize that with the source and the predicate. Because I'm an iObservable, I have to have a subscribe method. So when an observer subscribes to me, this is the method that is going to get called. Now, I don't want my observer to subscribe directly to my source, because that will give it the unfiltered data. So how am I going to get around that? Well, what I think I'm going to do is I'm going to wrap that observer, the one that wants the filtered data, I'm going to wrap that in another observer, which is going to do the filtering. So that's this where observer. And how does the where observer work? Well, it's another iObserver, and therefore it's got the 3 iObserver methods. It's got onCompleted. Well, let's see. When the sequence that I'm filtering, when that completes, my filtering listener, I want to tell it that the filtered sequence has completed too. If the source sequence throws an error, then my filtered sequence throws an error too. So again, I'm going to notify my observer. If the original sequence produces a value, then the filtered sequence may or may not produce a value. So I do this test of if predicate, and if that passes, then I'm going to pass that value on by calling on next. Otherwise, I'm not going to do anything. I'm just going to ignore that value. I'm not going to tell the my inner subscriber about it. This can be a little bit hard to get your head around because we've got 2 observables and 2 observers in play, it does work in a very similar way to the link operator if you look inside those. It is conceptually quite simple. It is basically the decorator pattern, if you're familiar with that. All we are doing is wrapping the iObserver that wants to attach to the filtered sequence. We are taking that, we are wrapping that in another iObserver which we can attach to the original sequence. When the original sequence pushes a value, that goes to our wrapping observer, and that wrapping observer decides whether to pass it on to the inner observer. In practice, the way that RX implements these things is not actually, it's often not, doesn't create all of those classes. There are shorthands that it provides, and if you're creating your own operators, then you will typically use these shorthands. And this is where, again, these primitives like observable.create come in. So I can just say, well, I want to create a new observable, and when someone subscribes to that, I'm going to subscribe to my source, my unfiltered source, with this callback, which will pass on the data I receive if that data passes the predicate. So this is a shorthand. One thing that it does do, although it may seem a little bit harder to read, it's more concise for a start. You will get the hang of reading if you start writing your own operators. One thing it does do is it draws out the relationship to the IEnumerable operators in a very clear way, and it means that if you're getting stuck, you can always think about, well, how would this work with IEnumerable, and then transform that understanding back into the asynchronous iObservable world. So let's look at the IEnumerable version of where. And you can see that's pretty simple. For each item in the source, if it passes the predicate, we're going to yield it. May not seem too closely related to the iObservable version at the moment, but let's take another look. Let's look at select. Here's how we would implement select for the iObservable world. We're creating a new observable. We're just going to subscribe something which does a transform before passing it on. And let's look at the IEnumerable version of select. Well, that's just doing a transform before yielding it. And we can see this pattern beginning to emerge where all of our observable operators are doing this observable.create thing, observer, arrow, return, source.subscribe, item goes to. It's a bit of a mouthful, but actually that just looks, that's, every time we see that, that's doing the equivalent of for each var item in source. So same up here, we've got that same boilerplate, and it's doing that same job as for each item in source. What about those yield returns? So both where and select included a yield return. Well, that's doing a yield return item that's doing an observer.onNext item. Select was doing a yield return selector of item, observer.onNext selector of item. So you can begin to see that relationship. We've got that for each corresponding to that kind of wrapping observable doing some anonymous subscription. We've got yield return corresponding to onNext. We've got the stuff that sits around the yield return and inside the yield return corresponding to the stuff that sits around and inside the onNext forwarding call. This is a very deep duality. The relationship between iObservable and iEnumerable is very profound in a mathematical sense. And if you go on to Channel 9 and look for Eric Meyer's videos, he's one of the guys who invented reactive extensions, one of the guys who invented Link, he will tell you about duality and the profundity of all this in amazing detail and in an amazing shirt. I don't have time to walk you through that. It's a little bit of a head spinner, but it's actually not all that difficult, and it is quite a beautiful thing to see. So I do encourage you to check that out. One thing I need to mention in this context is we've seen two kinds of observable, and actually there's a couple more. We've talked about those observables that we create from traditional .NET events. We've talked about observables that we kind of create manually using observable.create or observable.generate, where we're given a subscriber and we have to call things explicitly or implicitly on that subscriber. And this kind of ties in with two different views, or two different kinds of asynchronous data. With something like the mouse event or the file system event, the mouse and the file system just keep going. They have no beginning and no end, hopefully. In the case of a file system on Windows, maybe. But basically, there are things happening out there whether anyone is subscribed or not. Things are happening in the file system. The mouse is moving around, whether there are subscribers or not. In the case of our observable.create example, we created that with a callback that said, this is what happens when this is what to do when someone subscribes. So when no one's subscribed, what's happening? Well, nothing. That's not generating any data. It only pushes when there is something to push to. The Reactive Extensions guys call these hot and cold observables. A hot observable is something which kind of has values, produces values, pushes values, even though there's nothing to actually push them to. A cold observable is one that reacts to being subscribed to. And there's an important difference there in that if you build a cold observable using, say, observable.create, then you're kind of getting away from the time dimension. It means that when someone subscribes to you, they get those values. And if someone comes along later and subscribes, the same thing happens. You get the same push of things. So if you're building it's not a one-off thing. The same calculations will happen. A new object, a new sequence will be generated for each subscription. Whereas with something like the file system or the mouse, you've got one observable and you can have many subscribers to it. They will just dip into the stream of events, and at some point they can unsubscribe and lose interest. Incidentally, for unsubscribing, I've not talked about this in any detail, but that source.subscribe returns an iDisposable. Dispose it to unsubscribe. That's all it does. There's no magic going on there. All right. One of the interesting features of Link is that it supports two modes of operation. We've been looking at we've been analogizing with link to objects. So we've been dealing with events that are happening locally. We've been dealing with objects in memory, and we're comparing that to the link to objects implementation. But LINQ has also got this translatable model. So in addition to IEnumerable, there's a link to iQueryable. And people have used that to implement, for example, link to SQL, link to entities, link to Lightspeed, link to any kind of remote database you care to name, really. And the idea here is that instead of the query going out and fetching all of the data and then filtering it as if it were objects, which, if you've got a really large database, is not a great plan, the idea is that your LINQ query gets translated into something that can be run on the server, typically SQL. That SQL is pushed to the server, the translated query runs there, and only the results of the query are brought back to the code that is performing the query. I'm pleased to say that the Reactive extensions have got an analogy for that, and the reason I'm pleased to say it is because it has got the worst and most reprehensible name in the .NET framework. And I thought they were trolling me when I first saw this. So they call it iQueryable Observable. I call it iQuobservable. Because I speak the Queen's English, or the Queenglish, as it must now be known. It is the well. I've seen Eric Meyer's shirt. I understand what he was on when he named this. It's mad. But the idea with this is, as with a link provider, you can write an iQuobservable provider, which will take an expression describing your query, describing all the filtering and transforming and grouping and all that stuff that you want to do, and it will ship it off to the data source, which could be on some other machine or whatever. The query will run at that remote data source, and it will push data back towards you, but only the filtered, transformed data that you want, rather than an endless stream of stuff. So, in my notes for this talk, I had this innocent sentence saying, show a simple iQuobservable provider. Because we all know how easy it is to write link providers, right? Right. Who saw Ian's talk? Who saw Ian Randall's talk before this one? Okay, so to borrow his phrase, if you're afraid of writing a link provider, don't be afraid of writing a link provider. No, do be afraid. They're terrifying. So here is a class which is iQuobservable of process event. So that essentially, it is an observable stream. It is an asynchronous source of data. It isn't iObservable, because iQuobservable inherits from iObservable, but it is a remotable iObservable. It therefore has this magic method, in addition to subscribe, this provider thing, which says, this is the thing that is going to translate your innocent-looking expression into some hairy, hairy thing. And in my case, this is going to give me data about processes that are running on some machine using WMI. And because there could be a lot of processes running, I'm quite keen to have any filtering or transformation done at the remote machine end, so that if I'm only interested in, say, instances of Notepad being opened, I don't get all the other numerous instances of viruses and things being spun up. You all have viruses on your servers, right? Cool. So how does this work? Well, the magic happens in this create query method. And this is going to get past a link expression tree, which is not a query, but a description of a query. So although it looks like a query when you write it, same as with link to SQL, looks like a lambda when you write it, it's going to get transformed into one of these crazy expression objects. So I'm going to initialize one of those things, and when I get initialized with one of those things, when I actually start doing something with one of those things, I'm going to run this, when someone subscribes to me, I'm going to set up that query. I'm going to do it lazily because I'm lazy. And what am I going to do in that? Well, I'm going to create a query builder object, which is an instance of expression visitor, which is the hairy class that allows you to traverse a link expression tree and turn it into something that you can actually get your head around. And my expression visitor is very, very naive. All I want to do is build up a list of where clauses and a list of select properties that have been selected. And in order to do that, I have this visit method call, which is, I just need to override this visit method call, and I need to look for if the expression contains the where operator, the quobservable.where operator, or the quobservable.select operator. If it contains where, then I do expression magic. Yeah, don't worry about it. I do some crazy stuff, and eventually that is the piece of information I was looking for. After all of those lines of code, I can dig out, I can get into that member access, I can get into that where clause, I can pick out what comparison is it making, what is it trying to compare and to what. Similarly, I can plow through a select call and eventually, again, just dig out the name of the selected member. So once I've got that, I can use that to build a WMI query. And if there's no selects, I'll do a select star. If there are selects, I'll build them up into an appropriate string that I can inject into this WQL. Same with the wheres. If there's any wheres, I'm just going to append those criteria to my query string. And then I'm going to write my query string to the console because I have no idea what's going on at this point. I just need some debugging action. And then the actual meat of it, I create, and again, .NET 1 style, I create a management event watcher, potentially on the remote computer, and initialize it with that query and subscribe to its events. And when one of those events arrives, I just turn it back into one of the things that's been subscribed to, and I call, I feel glad to be back in the world of sanity. I just call on next, like we did in that observable.create stuff. I just push a value, and the way I push values is using on next. So, if I run that up, I should show you how I'm using that. Sorry, I should show you the program. There we go. So I'm going to start out just by doing a subscribe to all the processes that are being created. At the moment, my thing is only handling process creation. I should be looking at process deletion or process exit and things like that as well. But again, writing a fully featured link provider takes too long and is too scary. So if I run that up, then obviously I've set the wrong project. So we'll just we'll use that. So I don't know how well you can see there, you've just got that select star from instance creation event. When I start creating processes, you can see the names of those processes come up. But I can also put a where clause in there and a select clause. And because this is an iQuobservable rather than iObservable, those wheres and selects are actually going to get marshaled into the WMI query. And if you can see there, I'm only now selecting the name, and I'm only selecting it when it matches MS Paint. So if I bring up Notepad, nothing happens. Only when I bring up Paint do I actually get to observe anything. Does my subscribe thing fire? So iQuobservable is not widely used. There are not many implementations. I don't know if there's any real-world implementations, but you can imagine using it for something like Google Alerts, where you can create a subscription remotely. You could use it for, say, subscribing to a Twitter search, something like that. You could use it with, say, SQL Server Stream Insight, anywhere where basically you can query data in motion rather than data at rest. Before we go, I want to show you one small thing. People have trouble getting their heads around the reactive extensions because they're seen as hard, because they can be quite hard to kind of internalize. One little trick for this, marble diagrams. So for example, that is a select showing a transformation. That is where. There we have a take until. You can see how these things interact. That is combine latest. So when you see an operator that you don't understand, have a look for a marble diagram for it out on the internet. They can be really helpful in explaining these things. Time is difficult to get your head around. Dealing with these interacting operators feels more complicated than dealing with enumerables. But the payoff is tremendous. You can get much more readable code, you can get much more composable code. The mind shift, I think for a lot of people, the mind shift from writing imperative for each loops to link to link to object style code was not a small thing. I think it's been a really productive thing. I think it's resulted in much better coding structure, much more readable code, much shorter and more concise code. If you're dealing with asynchronous data, if you're dealing with devices, if you're dealing with messages, if you're dealing with anything that is unpredictable, these streams that you need to operate on as aggregates, then RX will give you that. RX is about what you want to do rather than mechanism. It allows you to think in link about asynchronous data. It allows you to think about how do I aggregate, map, filter these things rather than the mechanism of how do I attach to one of these, how do I attach to one of these things. You can declare your intention. You may not use it all the time. You may not use it as often as link because we have less asynchronous data now than we have synchronous data, but it is a really useful weapon to have in your toolbox. You can get the source from rx.codeplex.com. There's a really handy ebook. It's a free ebook. You can get it online or get it for Kindle from intro2rx.com. I found that really helpful for wrapping my head around it. And if you want to just get the binaries and start partying, then it's on NuGet. Just search for RX. All the slides and demos are up there on GitHub. Thank you very much for your time.